thanks everyone, first of all, for joining this this call, and thank you again, Justin, for doing the presentation. I'm Philip West from the CIBSE North East Committee. Happy if anyone wants to know anything more about the committee to get in contact with me, maybe connect with me on LinkedIn, and happily tell you about what we're doing in the region. Just in regard to the presentation today, if everyone can just keep their microphones muted while Justin's doing the presentation, and if you do have any questions, would you be able to use the comment box to put your questions in, and we'll pick all the questions up at the end. So thank you very much. I'll pass you over to Justin.
Great, thanks very much, Phil, and good evening, everybody. Thanks very much for joining. Appreciate that. And more screen time after a long day of work is not everyone's cup of tea, but thanks very much for joining. I'm just Etherington from BuroHappold. I'm going to give you a presentation this evening about low temperature heat networks and their future in the UK. It might be slightly different to as it was billed, which I believe you might be expecting a presentation around CP1 and the updates to the code of practice for district heating code of practice. I will mention it and reference it briefly, but I've got some slight crosswires, probably my mistake, so apologies for that, but I'll give you a run through sort of little introduction to BuroHappold, just for those of you that aren't familiar with us as a company. Heat in the UK, the big challenge that it is, heat networks and the role that low temperature heat networks can play. And then a case study of Plymouth, which is this photo on the right, which is a beautiful area of the southwest, so quite a long way from the northeast, but beautiful seaside nonetheless. And as Philip said, if any questions, please drop them in the chat box. I've got that up on my other screen, so if I can answer them on the hoof, I will. If not, we can come back to them afterwards. Probably about half an hour's presentation at most, and then a conversation. So hopefully this is something just to inspire a bit of debate, and hopefully you can all learn something today. And so with that, I'll launch into it. So my name's Just Etherington. I'm an associate director for the energy group in BuroHappold. BuroHappold, a multidisciplinary engineering company, started in the 70s. We started in Bath, and we've since split out globally as per our BH world map. So we've got a pretty significant presence in the UK. We're about 1,500 to 1,800 employees globally. So we cover the UK, significant amount of work in the Middle East, in Asia, and also in the US. So and Central Europe. So between those sort of clusters, we cover pretty much most of the world, if we can find the projects to do it. In terms of the what we offer, we offer a specialist consultancy and engineering support in most elements of the built environment. That covers from buildings, but also into cities and infrastructure support. We grew and started as a structural engineering practice, but very quickly our founder Ted Happold realised and was committed to collaborative design, and he realised that they needed to increase our offer from just structural engineering to building services, which went into other specialist services, and now we offer pretty much a full suite of services. We have the absolutely brilliant catchphrase to make the vision viable, but we do work on some extraordinary projects. Just a couple on the right there, it's the Louvre Abu Dhabi with John Nouvel, which is this large dome. We've done the arena in the bottom right there with this Iris Eye, which has the largest screen in it for entertainment. I don't think there's that many fans in there at the moment, but we cover a whole range of sectors, and like to think that we can offer a full service to our clients. I specifically sit in the part of the practice about looking at cities, and that's sort of everything between buildings. So my buildings colleagues look at all the building related engineering, and we look at items in connecting those buildings associated with the urban realm, built environment, to make great spaces. in that we offer quite a lot of strategic planning, but we also go through to detailed design. Some of the major strategic elements we've been involved in lately are the C40 Air Quality Action Plan. We're working with the C40 group for the global cities, and also the New York 80/50 plan, which was the 80% reduction by 2050, inspired off the back of the UK's Climate Change Act commitment. That's now probably superseded with a bigger commitment to net zero. Personally, I sit in energy. We are a group of about 25 energy engineers who are all committed to decarbonisation of our energy systems, and believe that distributed energy holds one of the keys to climate change mitigation, and that's what we get out of bed for in the morning, all passionate to try and do our bit. And today we're talking about district energy, which is one of the things that we think can make a difference, and specifically heat networks and heat networks in the UK. So there's only a couple more slides of corporate promotion, but we work for campus operators, new master plan developers, city governments, and utilities. So in the energy team, we cover all scale of projects really, and split our offer into sort of four quadrants, if you like, which is energy and carbon planning, actually design and delivery and performance of systems, infrastructure asset planning, so that's more mixed utilities, and infrastructure commercialization. So it's one thing to have a great plan, but traditionally utilities is seen as a cost. They're now increasingly a business opportunity, and it's something that can deliver revenue back to the client, or at least some cost contribution. That's very, very akin to some of the work that you will see happening with district heating, where you hear about concession agreements and that sort of thing. So that's really thinking about what the value of that infrastructure can bring over time. So that's what we offer to our clients. And I think everyone's aware of these 6 points, but we're at an amazing time in history at the moment, really, where we've got this cognizance of the damage that we've done to the climate and to the earth, and we're now really rapidly trying to backtrack on some of the development that we've made through actually a lot of fossil fuel use and high energy intensity use, and we're now trying to work out how to change our existing systems to move to an altogether cleaner operation, and we see that sort of six elements to focus on. The energy and carbon related with energy, so actually what's your pathway to zero carbon? Being clear with your utility infrastructure, so actually understanding what your risks are and what limitations you have from the systems available. More and more, health and well-being is an absolutely essential element to consider, as we all strive for better wellness in our lives and better balance. It's the reaction to climate change emergency, and on the back of that, the opportunities that we can get to moving to a more circular economy, and integration of waste streams, and all of that, as I'm sure you're all familiar and feel at the moment, is becoming more and more digital and digitally integrated, allowing us to hold events like tonight, like this evening. So in an energy perspective, we all know this, the energy system is changing. Baseload is dead is a bit of a sweeping statement, but baseload is reducing, and distributed energy is here. It's a slightly outdated stat from National Grid, but we've had almost a 60% reduction to 2019 since 2013 in carbon intensity of the power grid, which is fantastic for the power grid. But what remains is heat and gas, and our strong habit in the UK that we have of using gas for heating, and how we make those changes and decarbonise that is something I'm going to talk about today. So I'll just touch on this briefly, really, to help sort of set the scene a little bit. Everybody's talking about net zero, but really, what does it mean? I'm not sure this chap on the right knew what it meant. I'm still not sure what quite he knows what it means. I'm not sure any of us have really grasped it totally, but we became, the UK became the first major economy in 2019 to reset our commitment to net zero by 2050. Absolutely fantastic to have that as a part of our commitment, and really helps focus the mind that we've actually got less than 30 years to make that transition. So you might have seen today, splashed all over the place, the government's finally come out with their 10-point plan to reach net zero, which has a number of issues. It's about £12 billion worth of investment. From a preliminary scan, I will confess I haven't read all of the details of it, so there may be some items that I'm not fully sure of, but what I have been able to pick out is that things related to heating are really under three items I can see, which is there's a mention of the use of hydrogen in homes, which can only interpret as going towards heating as a gas replacement. So there's a contribution that hydrogen can make, and that's a big topic of discussion at the moment. As I mentioned, the public sector in the public sector element number 7 there of improving home, schools and hospitals, and there's in the text under that there's a sort of 600,000 heat pumps per year delivery by 2028, and also mention of an additional year to the Green Homes grant that's currently in play, which is good news, but as to what sort of dent that's going to make in the UK's existing stock remains to be seen. From what I can glean, lots of the providers are already absolutely stacked out, so there's likely to be a supply chain issue there. But importantly as well, there's funding for innovation and continued innovation to allow us to continue to develop and remain a leader in this. So at BuroHappold, we really subscribe to the UKGBC net zero carbon buildings frameworks that they've been promoting, and around operational energy and also in construction. If we're to take net zero seriously, that's we have to adopt these sorts of items and work with them. At BuroHappold, we're committed to net zero operational by 2021. So that's coming around pretty quickly as a company, but we're trying to walk what we're talking. So what does a design approach to net zero look like, and how can district heating play a role in this? So we focus first on energy savings, maximize, looking at reduction of demand. It's going to play a central role in this. Then you look at on-site renewables and low carbon technologies, and then off-site renewables and what you can directly associate to your projects with off-site renewables before moving into the compensation measures. But it's a full system solution that we're going to need. So if anyone's under the pretense that we can achieve, especially in a city environment, that net zero directly in sight, I think that's a really big challenge. And so we need to think bigger than just the specific projects we're looking at. Heat in the UK is around 32% of the demand, something around that, and that heat really goes towards space heating and water heating with an amount to process load. But the challenge that we really have is how do we get off our natural gas boilers that we have at the moment. You will be probably familiar with the proposal to ban gas boilers by 2025, or at least there's a motion to ban them from new build by 2025, which I think is a really good thing. It does mean that we've got 5 years to get ready for that, which I think the industry is adopting now and moving very quickly, and some of the policy changes that are coming through are already pushing us as designers to look at heat pump based solutions. So the Clean Growth Strategy outlines further support for heat networks with public funding up to 2021. So you may be familiar with the Heat Network Investment Project, which is £320 million ring-fenced for the support of heat networks. That's running to an end in March 2021, with the Green Heat Network Fund coming after that to continue support. There's the point 18 there is the phase out of the gas grid for new homes, and that's what district heating needs to compete with and work within as a framework. Andrew That's a good question. How the ban on gas boilers will work with a move to. Okay, Rachel, apologies. I hope that's not my bandwidth. I've turned all my other elements off. In terms of how gas boilers will work with hydrogen, I think my personal opinion would be that that's more going to be for existing buildings that are still connected to gas boilers, and so when we're talking about the ban of gas boilers, that's likely to be about new development, or is more attached to new development. So it's trying to avoid having new developments pegged to a higher carbon future. So specifically for heat networks, what's the plan? In most scenarios that you can look at, is about 17 or to 20% of future heat by 2050 is provided by heat networks, which is an enormous expansion from the 2% that we currently supply. But in most of the strategic documents that you can find in the target setting documents, there's not really a plan as to how we're going to roll that out. So it's really left to the market to try and deliver these systems. So coming back to where heat networks can contribute, for me, they sit in this area, which are direct measures that we can take. And those are direct measures for our projects, and these are really allowing us to provide on-site renewables that could potentially feed into a heat network, but also sharing low carbon technologies locally. So heat networks are for supply of energy and sharing of energy, and they should be considered after the energy conservation measures have been maximised on site. So they shouldn't be seen as a substitute for energy efficiency measures, which I think in certain cases, certainly in London, previously under the London plan, we were able to secure incredible carbon savings through the use of CHP, which meant that actually energy efficiency measures maybe weren't maximised as far as they could have been, which is probably a missed opportunity. So that's where I think that heat networks can contribute, is to share and provide low carbon heating to developments. So what have they been traditionally, and what do they look like in the future? To many, a heat network is absolutely synonymous with a big energy centre with a chimney, which is really more of a boiler house than an energy centre. So traditionally we've had gas to the energy centre, gas burned in the boilers and the CHP, and then a high temperature distribution, maybe 80 or above, out to the buildings who use the heat in the buildings. And that's been very much a one-way system. Where might it go in the future? So hopefully you may have, well, in terms of heat networks, they talk about heat networks in the industry about generations. Be a little careful just talking about generation, because there are some fundamental architectural differences, system architecture differences between some of these generations. So from 2 to 4+, these are all centralized networks that would distribute heat from a single point and share low carbon heat. As we go through generations, we look at currently the sort of industry standard has been 3rd generation, which are supply temperatures of below 90 degrees with return temperatures around 70 degrees. We then started looking at 3rd generation plus, which have higher temperatures but allow some flexibility using weather compensation in the summer to reduce temperatures, but are still relatively high temperatures. And then we're looking at 4th generation, which is really, I suppose, where a lot of the industry is moving towards, which are lower temperatures below 65, hopefully below 60. And those, from here, from the 4th generation, we're really getting into where there's high compatibility or higher compatibility with low carbon heat sources such as heat pumps, and that's where we can begin to get competitive efficiencies. competitive efficiencies and operational ease of operation with low carbon technologies. And then as we move to 4G plus, these are driving down temperatures even further. But these, everything in 2 to 4, all depend on the fact of having a energy center with passive users. So you're providing a heat which is ready for use, or a commodity which is ready for use. And then we have a big jump between that system and into a 5th generation system, which sometimes referred to as an ambient system or an ultra low temperature network. And in that case, you've got very low temperature water, maybe between 10 and 30 degrees, which you're then upgrading for use in the building with decentralized plants. So you have to be a little bit careful about mixing system architecture between what is primarily a distribution system to something which is an energy sharing network, and decentralized, where you actually are doing the active work in the plant room. So those of you that are hoping to hear about CP1 and CP1.2 today, unfortunately, this is where I'm going to reference it, which is really CP1 is a fantastic document generated by CIBSE to bring some guidance to designers and support to clients as to the process of best practice to deliver heat networks in the UK environment. Launched in 2015, the first generation really covers 3G and 3G plus networks. So it's there serving as the basis and introduced a number of good, really useful guidance for designers. But in my opinion, it wasn't really strong enough, or isn't strong enough. And I was lucky enough to sit, or happy enough to sit on the panel for the chair, or the committee for the drafting of CP 1.2, which is due for release imminently. I'm informed, been through final layouts now. And really what CP 1.2 does is it brings us through and starts to bring us into the 4th generation 4G plus areas, with big changes from CP1, big changes being around diversity, much stronger guidance on diversity for domestic hot water, also diversity for space heating, as well as stronger guidance on the temperatures required for domestic hot water, which is absolutely essential to nail down temperatures to allow us to deliver the maximised amount of low carbon heat from heat pumps. But CP 1.2 doesn't yet stretch into the 5th generation, and so it is a little bit unguided at the moment from a 5th generation perspective. I think a lot of people are working at it. Technically, you will have seen a lot of manufacturer information around from Dimplex and other manufacturers who are looking at building level or individual unit level, effectively 5th generation systems with shared heat loops, but there's not a great deal of guidance around that on a larger scale. And there's certainly a challenge in the business models on the 5th generation at the moment. So what do we do about heat networks? So millions of pounds have already been invested into traditional heat networks, which are operating, some of them operating well, some of them having teething problems, and I'm sure everyone's heard of a number of those systems which are really struggling. However, a bigger problem that we've got in the context of net zero is that a lot of those systems are fossil fuel based, have business cases that were built around CHP. So as the grid has decarbonised, they're losing their competitiveness environmentally, and so they're now stuck operating as a commercial investment that needs to burn the gas to make the business model work, but they're not providing the savings they were. So what do we need to do as a heat network industry? What do we need to do to continue proving the worth of heat networks, and how can we evolve heat networks to make them more relevant? I think one thing I would like to bring your attention to here is the comparison of the UK thermal demand and just how heating biased we are from this information. This is also from the Clean Growth Strategy, I believe. But we are effectively a heat dominated country. So I would just make sure that when you're considering heat networks or heating systems, we really think about the relevance of a 5th generation system and whether the demands really warrant it. So what is a 5th generation system? It's a concept which allows us to recycle energy, and in terms of ambient loop operating at 25 to 35 degrees, is that a 5th generation system? I would class it as a 5th generation system, Phil, because you need to make that 25 to 35 degree heat useful. You need to upgrade it at the point of use, so you still need to put useful work into it. Whereas a 4th generation system for me is something that you can where you get a heat that you can use directly, so through a heat interface unit or through a substation, and you can use that heat directly in your building at 25 to 35 degrees. The likelihood is you're going to need to upgrade that for space heating or domestic hot water use. So what you're trying to achieve with 5th generation heating is combined heating and cooling. So it's the ability to deliver both heat and cooling, but really it's to share that energy. So we're not just blowing rejected heat out in the atmosphere in the case of chilling, but we're putting that into a system that we can capture it and use that to go to provide our summertime heat loads or our complementary heat loads. So just talking through this schematic, what we've got on the right here are the buildings, and the difference you'll see is we don't have here a centralized energy center. What we have are sources, so sources of heat. In this case, we've got boreholes, open loop boreholes, which we're using in, which we're proposing in a sort of storage arrangement. So you've got effectively 2 headers where you've got a hot store or a hot well and a cold store and a cold well, and joining those together you've got two networks, so a flow and a return, but they're bi-directional. So depending on the requirements of a building, they either suck the heat out of the hot side of the system or reject it and reject the cooler heat back into the cold side, or if they're cooling, they suck cool out of the cold side and put it back into the hot side. And that way you've got an ability to share heat not only within the building but across the network between buildings, but also in this case coupled with an open loop ground system across seasons. And what we're looking at there is really reducing and recycling the amount of energy that we need to put into this system. So you're getting increased efficiency on your heat pump when you're heating, but you're also getting increased efficiency on the cooling because you're able to provide into your chiller lower temperatures than, say, in the summer, a 30-degree air temperature. So that's the 5G concept as we see it. There are other other interpretations of it. Heat networks have moved through the 4th generations, and I think we're at the 5th. The real challenge we've got in moving to electricity is really gas is very cheap and power is relatively expensive. But technically speaking, there are a number of things that go towards supporting a move to 5th generation. Is that you can have ambient temperatures piped in the ground, so actually you can get away with uninsulated pipe, which is much cheaper and quicker to install. You're able to have a more plug and play approach to things, so you don't have to size a big energy center to start with and wait for demand to come. You can add additional heat sources as you build capacity. So that could be additional geothermal wells, it could be additional river exchange, it could be seawater exchange. You can and importantly, the thing about an ultra low temperature network is you can genuinely recover secondary heat. So you don't need a certain grade of heat. Your carrier fluid is lower enough to be able to accept all sorts of heat and cooling as you need to balance the network, which is, I didn't mention it, but which is a problem with a fourth generation system, is that if your supply temperature is 60 degrees, to recover cooling into that, you need to raise any rejected cooling up to 60 degrees, and that's an increased cost in energy to do that. So I'm going to give you a quick run into a case study for fifth generation that we've been working on in Plymouth. I've been working with Plymouth City Council now for about 5 to 6 years. Plymouth, for those of you that don't know, is quite a long way from yourselves. Down here in the southwest of England, it's a seaside city. We have been through the Hindu process of energy mapping and master planning through to feasibility studies, and are now currently looking at some detailed project development to help Plymouth with their decentralized energy targets and how they and their strategic plan to decarbonize the city. On the right here is the output of our heat mapping, which identified that anything in those green zones are referred to as heat network priority areas or district heating opportunity areas, and anybody developing in that area, due to its higher heat density relative to the city, anybody developing in that area needs to inquire about district energy connections, which is the first step to making sure there's engagement, that opportunities aren't missed. We have looked at the development of through an Interreg funded project, which is a European funding. We looked at the development of a fifth generation network in the city centre, largely outlined by the sort of sketch you see on the right there, which is to do with picking up a civic centre, which is an existing building just going through refit. The pavilions in the right hand side there, which is an event space, but this area down here is called Bath Street, a new hotel, some new residential, some student blocks, and Plymouth City Council's headquarter. And through this project, we're able to go and look at HEERLEN in the Netherlands, which is a fully functioning fifth generation system. In HEERLEN, and apologies, this is a little bit techie, but we looked at what they've done to deliver 5G, because we were really quite looking to learn from precedent. And what is interesting to come out of this is, so far from what we can ascertain, they've had about 60% grant funding secured to date, which is an enormous amount of investment into a project. And also in Holland, they have a much lower spark gap. So they pay about 6 pence per kilowatt hour for gas, sort of similar cost for power. So actually the competitiveness of electrified heating is much greater. And they've got absolutely solid governmental support to support the move from natural gas. One, because their supplies are draining, but also they have got some real local issues to do with drilling and tremors coming from that. So there's a commitment nationally to move away from gas. So we think that that's one of the reasons why the HEERLEN mine water project has been so successful to date. But it does set a precedent for how technically you can do this. So a little bit of technical detail now. We're starting this project with the Bath Street cluster, and this is a small cluster to really prove the concept of fifth generation. That involves borehole installations which are shown by the two blue squares here, which are the initial wells, and then we'll have future boreholes in the as per the red dots. This spine down the middle of the drawing here is 300 mil plastic piping, that's just been installed at the moment, and that will allow for this hotel here, a new residential development here, and the pavilions to be connected. The principle, and apologies if you can hear some fireworks in the background, someone's having a party. The principle is that we will have a heat dominated cluster. So what you're looking for with the 5th generation is heat balance. In this first cluster, we've got a heat domination. And so that means that we have to depend upon the regeneration of the wells, which means that our hot well will tend towards a sort of a 6 to 12 degree temperature. But in the future, as we add more commercial onto the scheme, we'll get a greater balance between cooling and heating. But the advantage of this is we are able to deliver free cooling directly into most of the uses. We've worked this up into a sort of schematic in each building where you've got a heat pump between heating and cooling circuits, which allows you to share heat at a building level directly between heating and cooling circuits, but it also allows you to reverse the direction of the circuit. So if you're in cooling mode, you'll take water from the cool well and run it through the heat exchanger to provide for cooling. If you're in heating, and then you'll effectively reject the gained heat into the warm well. If you're on the warm side, you'll take it out of the warm well, run that through the heat pump, and then reject the cool into the cold well. And so that is something that we've worked up as a standardized detail that's gone into some connection packs for the council. And we've also been working with BEIS to look at the challenge of actually how you launch this as a commercial prospect. It's one thing to have a nice technical solution, which is what I was just talking about, and theoretically it works well, but actually these things are infrastructure projects, and can't be done just at cost value. So you need to get into this, which we sometimes call the circle of doom, which is a little difficult to break, which is, and it doesn't matter where you start, but let's start with up here, that you any project that you have needs a business case. That business case needs funding, so someone has to pay for it, and funding is generally uncertain without customers if you're looking at a heat network project, because the long-term returns are dependent on the revenues, which are dependent on customers. So until you get some customers, you've got uncertain funding. But the customers on the flip side need compliance, so they need a system that's going to work for them and get them their planning, but they also need certainty, so they need confidence that what you're proposing is going to be built. So you then get into the next part of the cycle, that your business case needs customers, and so you can see how this can turn into a long-term vicious circle that keeps on going round until you nail something down and get some confidence. So what did our exercise look at, or what did our analysis turn out? It turns out really that ground source heat pumps and systems are inherently more expensive than the counterfactual, so it's a high cost system. As we take CHP out of the equation, we remove electricity revenues, which means it leaves operational viability gaps, which means, as we can see it, it makes RHI, or an incentive to enable heat, absolutely essential to give any sort of level acceptable returns in the UK. So for this particular project, RHI makes the scheme investable. And the challenge that we've had, that this project's been riding over, as I'm sure some of you will be aware, is that the RHI scheme has been under consultation. There hasn't been consultation response that's come out, but it's still very unclear what the follow-on support could be. So we've got uncertainty from a funding perspective, which means there's real significant risk in the project. So you can see on the right here, of our annual revenues that were modelled, a significant amount was coming from the RHI incentive, and that gap there allows you to make your profit and pay off your investment. The other learnings that we've taken from this is that you need proactive customer capture to go out and make this work. People aren't going to do this off their own back. They need to be guided and they need to be supported. So what we've developed with Plymouth, and with lots of thanks to Bristol City Council, who are also who are really trailblazing in district heating network, is that we've developed connection packs for compliance, so to help designers know what they need to design and what's expected to be designed, and that's for the 5th generation as well as 4th generation networks. So to take away some of the uncertainty about what should be done, we've helped them with some connection packs, and we've also developed an approach which allows for heat supply to be achieved with the heat pump system prior to the arrival of a 5G network, and that's represented here by the two schematics you can see. On the left here we've got a building. This is the heat pump, and it's domestic hot water heat pump, but we've got the heat pump in place that you'll need for your long-term connection. But in the first case, we've got it connected to an outdoor air unit, and that allows you to effectively operate this building electrically without the water connection. And then in the future, you can transition to connect your 5G or low temperature network into here, and then either you can retain this the air exchange for resilience, or you can take that away and use it another connection to provide the same future flexibility. And that's something that we think really must be worked on harder and implemented by district network developers to avoid losing connections. Too often the network comes behind, and therefore you lose the confidence. But if you're prepared to go out there and offer a heat system from the off, that will you can already enter into a contract, then you're capturing future customers. So we developed with Plymouth up a timeline and a roadmap of engagement that needed to be undertaken for what the government needed to do, what Plymouth City Council needed to do themselves, what the promoter, who in this case was Plymouth City Council, needs to do to go and develop the system, and also what the developers need to do, and how you connect existing buildings. And we're working through this with Plymouth. We're currently here in the 4th quarter of 2020 in the process of signing off a business case for heat supply, and we're continuing work with the developers to ensure that the connection in principle is being developed as a proposal. So the summary sort of our roadmap can be summarized in 6 points, really. I still believe, even now, with that RHI needs to be replaced with some sort of other incentive for electrified heat to really fly, because gas is too competitive. You need to have a policy which outlines zones to encourage people to connect. You need to enforce and have a stronger enforcement of compliance systems, so more guidance for designers to help take out the variation in system and also variation in interpretation, and that's something that CP 1.2 helps to support. From a more practical perspective, you need to early on establish a body who's going to deliver this heat and really go after customers. So you need to be clear that you're going to be a heat network provider, and that's is more like take the form of an energy services provider, and need to focus on that. And to do that, that allows you then to go and get heat supply for developments in place in advance of a network, and then you need to come back and connect the sites. Too often, I think we're trying to hold out in the district heating network sort of arena to go and make the final scheme straight off the bat, and that just doesn't really happen. So very quickly, delivery in practice. I'm aware that I've waffled on for far longer than I was hoping to. We've actually had the win with Moxie Hotel, and we've got temporary dry air coolers in there, so that has happened, and they're happy to install that. That's fantastic. It's very difficult to convince large multi-tenant developments to come along and connect to a district system. That's really a real problem that we've had talking to a big multi-use developer with national assets. Even though they're identified as a key user, they felt they could make compliance by not connecting, and use some and have just lent on sort of traditional approaches for installing VRF and fit out on different units, and that makes effectively the sort of 5G approach impossible, because you've got a very messy retrofit connection. So it's been very difficult to try and actually agree. And positively, we've got 200 meters of DN300 pipe installed, and we're progressing to look at developing that first network that I showed you. And we've been drilling holes. This isn't me on the right, but it's Aaron Powell, who's an engineer in my team. It's our drilling rig. But for anyone who hasn't tried drilling holes yet, it's very challenging. It's unknown until it's proven. And so far in Plymouth, we've had yield issues sort of contradicting all the desktop information. We've had operational challenges with actually drilling. And you're going to need multiple boreholes and probably multiple heat sources for 5G. So you need to have a wide scope of heat sources in your artillery, just because until they're proven, then nothing's guaranteed. I think we're really struggling in this country, just basically because these projects do need more funding until we can demonstrate their operation. In Holland, as I said, there's much greater funding. There's a more competitive cost due to the spark gap, and there's bigger central government support to move. So what are the next steps, really? We need to design systems for the demands and not the trends in technology. Yes, I will share the slides. We need to consider alternative heat sources and really think about how we can integrate them. And we do need to keep building confidence through regulation. So we've got design standards coming. Design standards through 1.2, CP 1.2, really helping push the limits of what we can do. And from the consumer perspective, we've got off-German regulation likely in the coming years. But the heat network community needs to move quickly. And we all need to keep lobbying for support, because I think without industry saying that it's very difficult to do these things, the pain is going to fall on the customer for the systems that we put in. And so we do need to keep on making clear the need for support until we can, if carbon reduction is what we're all trying to get to, then there needs to be more support to pay off that cost of carbon, or the relatively cheap cost of carbon that's associated with gas at the moment. So thank you very much for listening. If you're still there, that's my presentation. I'm more than happy to take questions now. I think there's been a couple that have just popped up that I haven't managed to head off yet. Jess, in terms of the spark gap, why it's narrower in the Netherlands is that they have a gas price of 6 pence per kilowatt hour, and we have a gas price domestically, probably we all pay at home somewhere around 4 pence a kilowatt hour. It can be down as low as 1.8 to 2. So we've got a really, whereas our electricity costs are almost the same. So gas is much cheaper for us in the UK. Any other questions?
Justin, I think there was one from Andrew, I think, just a little bit further up, about the frosting up in high heat demands.
Hi, Andrew. That's a good question. So we've got a defrost cycle in the dry air coolers, which allows us to. There's a small parasitic sort of loss that you get from doing that, but the fans cycle out one by one to retain operation during the coldest of winter months, when you get freezing. So that's how we're dealing with frosting up. There's a small penalty in the COP, but that's the design solution at that point. There's a question here. Ali, I don't know if you want to just, what was the question about data centers here?
Hi, can you hear me?
Yeah, got you now. Great.
Yeah, it's regarding basically London planning. We need to connect the DCs to the heat network, and there is no guidance with regards to that. How this need to be basically connected to the system.
Good question. I mean, I think, you know, principally where we've been designing, we've always got an agreed point of demarcation as to where the system boundary is. In the 5th generation pilot in Plymouth, that demarcation is the preferably includes the heat pumps within the system operator's package, and you have a clear line that the building side load is on the other side of that. In terms of data centers, I'd assume that you draw your demarcation at a substation changer, which could be located in the plant room.
Yeah, it is on a roof actually.
Okay.
So there would be a long pipe run from the roof,
yeah,
to the actual boundary of the site, to the so I'm just wondering whether the authority are willing to pay for that waste.
It's a good question. I think to be quite honest, the challenge that you have in the 5th generation is how do you set pricing for waste heat, and how do you which is a sufficient price to make it worthwhile for those rejecting heat, but isn't overly, it doesn't penalize the operator in terms of trying to use it, and that's something that's not yet. I don't think there's an exact science around that yet.
Is there any design guidance for?
Not that I've seen specifically. There's some useful 4DHC things from the IEA where you might be able to find some guidance.
IEA.
Yeah. I can try and send some links around Robin Wiltshire and his team.
Yeah, I would appreciate if you could share some text to review. Many thanks.
There's quite a number come in, and there you go. So my other screen's having a moment, so I can't quite see the see the questions. There are we. So Valeria, regarding the peak heat demand, what we're looking at is heat pumps in parallel with or supported by thermal storage. So you're using thermal storage for your peak lopping, and using that you can reduce the size of the heat pump you need. At that point you do have to subscribe and buy into the fact that you've got a peak load which is higher than the installed peak capacity that you have, and you have to trust in the fact that you have sufficient storage to deliver that. We haven't been including for direct electric as a peaking technology at this point. So Rabbi, in terms of the grid infrastructure, I mean that's a reason that, as I said at the beginning, that we do need to continue supporting energy efficiency, and that's why, in my opinion, using direct electric isn't really a responsible solution, because we're already going to struggle with the decarbonisation of heat through heat pumps to manage that on the in the electrical network, and as to who's going to pay for it, I mean, ultimately it's going to be the consumer. So as an industry, we need to be thinking long term as to what we can reduce in terms of demand. And I personally think that whilst there are complexities with having the hydraulic systems that come with having heat pumps, the fact that we can have a three time lower power demand than direct electric is of much greater value than we're currently thinking about, and currently really able to put a value to. Tej, do I anticipate the spark gap to narrow? I mean, there is discussion at the moment about changing the pricing and levying some of the cost of carbon into future gas prices. So hopefully that would go up significantly, if you like, to make electric systems more competitive. Obviously, that needs to be managed in the context of all of us that are effectively trapped into the gas systems that we have at the moment. So whilst looking for future business systems or business opportunities, be able to prove that gas is going to be more expensive, electric is going to be cheaper, is going to make a new proposition more attractive. Until there's enough responsible support to allow people to make that switch, it's a fine balance as to how much you can increase the cost of gas. And there's a very strong gas lobby out there also promoting the longevity of that industry. But I think you can really see in the domestic scale the amazing work that Octopus Energy are doing with other heat pump manufacturers and their agile tariff to really promote how heat pumps and demand side response can be rolled out at a low sort of a small scale, and that's only get bigger at a sort of industrial scale. And that's one of the things that we want to investigate with the 5th generation, is what can we do for demand side response, and how does that help support this multi-vector approach of power and heat supply coming together. So that's one of the things we'll be looking into, is delivering flexibility, but the spark gap, I think, there'll be a managed closing of it. Chris, in terms of natural gas in a combustion process, I think the issue that we've got around fuel cells is just still is still the way you get the feedstock from with fuel cells, is that they are effectively they're turning something into they might have a more efficient combustion or utilization of natural gas, but you've still got gas going into the system. And we're trying to make the 2050 goals. We've got to move very quickly. So fuel cells, in my opinion, will be applicable in places probably where you've got hydrogen hubs and that sort of thing. And maybe fuel cells will play a role if we're able to blend more hydrogen into the gas network. I'm personally somewhat skeptical of how far we can get with that, but I remain very open to the fact that it may work. But at the moment, I'm very focused on trying to work out the electrification of heat at the moment. But there's everyone will have seen a big national push into hydrogen, and so I think that as a vector, which you must remember, hydrogen is a vector, is a way that we can store energy and then redistribute energy. So it's going to be one of the ways that we can capture some of our massive renewable overshoot that we'll get from large wind deployment and large solar deployment. Damien, flow temperatures does not drive the flow rates. We have lower flow temperature transition, and temperature transition is something you've got to consider in terms of the mass flow rates that you've got, and that's why often your move to a lower temperature system needs to have energy efficiency associated with it to reduce the demand of the space. Therefore, as you reduce the output that you can get out of a radiator, for example, with a lower flow temperature, you can match that with a reduced demand. But yeah, that thing of transition with existing systems, as you picked up, is a really live challenge, and one that we're all looking to address. I think what's quite interesting, just doing some work at the moment also with Plymouth, looking at heat pump deployment, and seeing what we can do with weather compensation and heat pumps that can achieve a higher flow temperature, just more on an individual basis. And we're finding that there's, with weather compensation across the year, we think that actually quite a lot of the existing systems can be retained with relatively minor or with manageable amounts of energy efficiency. So I think that's something that we're beginning to get a better understanding. Derek, in terms of boreholes, I mean, the real issue is that until you drill the hole, you don't know what's under there. So we have lots of historical records and hydrogeological maps, but until you drill in and confirm that you get the water out of the specific hole you've drilled, it's unknown. In terms of further research, I need to inform myself better. But what I can say is that we had the best level of desktop certainty that we could have in Plymouth, and we've been very challenged to realise the yields. And it is something that is, I think that ground source energy is something that is quite challenged by the very quick development in air source technology at the moment. Chris, question about cascading. Yes, we were assuming, and sort of there's a number of ways you can look at it, but we were trying to reduce space heating temperatures as far as possible, and then having committed domestic hot water booster top-up pumps on the back of the space heating circuit, in that sort of cascade configuration that you're talking about. And really what you're trying to do is drive as far as possible supply temperatures down. Alvaro, the lack of regulation is right at the moment. So a lot of the projects that you'll see being developed are with local authorities who have the highways under their effectively under their wing, and so licensing is available. Some local authorities have installed heat networks under permitted development. Some heat networks, or some authorities have required planning permission to deliver it. I mean, I think we mustn't forget that installing a heat network is effectively like installing a utility, and they have statutory undertaking powers, and that's something that's being consulted at the moment to allow for heat network installers to be able to have the same power as a DNO or a power network operator to be able to dig up the road when they need to fix their equipment. So and to install new elements. So it needs to be managed, but I think that's something that we'll see is a greater power soon. In terms of what happens in the future for DN 300 pipe that comes to the end of its lifetime, like any asset, there needs to be a managed replacement strategy for it. So that could be doing a sectional replacement with some temporary heat supplies for those elements that are impacted by it. I think with most heat networks, you'll see most designs having a contingency solution which allows you to install an alternative heat source at point of use. So you do need to consider that replacement as with any asset, and pipes are a lot less flexible, if you like, in terms of replacement than drawing cables, but we have the same issues with strategic water mains and the water systems. So it's really a managed replacement, but I think probably not enough consideration is put into the long-term future replacement. Struggling to keep up with a few of these. Chris, I think you're right that the regulation is going to be something to do with Ofgem, and the heat trust are in discussion as well, but Ofgem seems to be the direction it's going at the moment. it's not quite clear what role they're going to play. But I mean, I personally think it's great to have a more official regulation to protect the consumers. But what is important is that the CMA report that was released last year, which looked into the cost of district heating, found that in a few isolated cases it wasn't delivering value and had a very high cost, but in average it was cheaper than alternative sources of heat. And I think that's a message that's important. So there's always there are always poor performing systems, and that's true of any sort of any type of any technology. But those big scare stories shouldn't damage a whole industry. And it's important that our role in that is to make sure that the quality that we produce going forward, and the way that we're able to go back and mitigate existing problems is helps fight that and shows that performance can be achieved. Absolutely, Stephen, in terms of if the cost of power goes up, then trying to keep electrified heating systems competitive versus gas doesn't really help. So there's a real challenge here. If the pipe fractures in year 5, then you repair it. I think it's Martin, really good question. Really struggling with the economics, to be quite honest with you. I think most people are, and it works with as I showed it works for a reasonable rate of return with investment incentive support, but we're really struggling with just flat out with an unsupported business case. So it's, in my opinion, not yet developed as to quite how you roll 5G out, but from a technical perspective, it does give you fantastic energy sharing opportunities and energy efficiency. So there's a bit of there's development to be done. If you look at the sort of the way the heat industry is looking at heat as a service and things like that, those sorts of approaches and more commoditized retrofit will go in, I think, as part of the development of these systems as a sort of overall end-to-end package. I think once you start to pack those different approaches together and stack them together, that's how we'll be able to make the overall these systems come good. I think I'm probably nowhere near the bottom of them. I don't have a study to compare carbon savings from gas against electricity top-up heat. I think in our sort of calculations, the main point is that our current grid performance is so much lower now than gas that even if you've got a very poor COP, you're probably half the carbon intensity of gas. So I think we're really, it's becoming so much more competitive. We're getting to a stage now where it's very soon on a number of days in the year where direct electric heating is lower carbon than combustion of gas. So I think we're only moving in one direction. I think that sort of calculation, and really the big question I'm sure some of you will see on your new developments is what is the counterfactual, and gas boilers is soon to not be a counterfactual if it's not already been replaced. So the sort of arguments are moving very quickly. Yeah, it's a really great observation about the difference in or what heat pumps will accept in terms of different temperature differential. I think one thing that you can be, we need to be cognizant of is how you connect hydraulics together. So you can also split hydraulics between sort of lower temperature differentials of the 5-degree DT that your heat pump wants to see, and your rads and your rad pipe work. That's maybe. And I think there's probably a crossover point where you see that of scale, and maybe at a domestic scale, having oversized pipework isn't such a penalty. But when you're looking at more commercial blocks and larger blocks, then you need to be driving bigger delta T's on your heating systems, because the cost of the network element becomes so great. Whereas maybe when we're looking at the difference between DN15 and then DN20 around the house, maybe that's maybe less critical. So I think that's probably how I'd see this question here, Stephen, about delta T. I think that also goes, Damien, towards this split, is that you need to look at, for me, it's really about what you're looking at, the temperature that you can split the temperature level or delta T difference, delta T's between the primary and the secondary side of systems, which I think allows us to get to two supplying existing systems. So, I mean, there are heat pumps on the market now that will do up to 85, 90 degrees. In terms of strike temperature, what they need is they need a low enough return temperature to function, and getting that low return temperature is something that's really important, which is more of the challenge in what we're seeing in existing buildings. And I'll do just mindful of the time, that yeah, quite long. Any more questions? It looks like people are signing out. So I think maybe any more questions? You've got any more questions? You just pop them in the bottom of the chat now. Otherwise, but I'd say it was a really interesting session.
Yeah, thanks very much, Justin. It's been a very well attended seminar, and obviously very much thought provoking in the topic you've discussed as well. So yeah, thank you for doing that, and thank you for everyone for attending and posing the questions to Justin. He's probably well earned a drink after answering all them questions. So thank you very much.
Well, thank you very much for the opportunity. And that was, I'll send around the slides.